switched around dynamic, vertices dynamic being the allocator, this going to the originally. Should start writing some classes, but it's like first I need the base to work. And I tried that. That didn't work. The only other thing is I could try is making it to dynamic. I tried to printf this, but it wasn't defined yet. So after you increment, this is not going to be defined. What if we put this here? Let's see what this said. It's better to press escape. It actually deallocates. Yeah, so it's right. It's in there. We could also do this. Take this crap. Right before we pass it in. I know we're passing this one in. Let me set it back to this one. And memory address of that. And it's passed into this vertices 44 for whatever reason I had to call it that. So let's try to print that out. Vertices 44. Offset 0. So that just technically says cast this to float. So what it should do, the only other thing I didn't check yet, which I'm suspicious of, is the C++ version. Default ISO standard C++ 14. Yeah, so it's like the lowest. So why doesn't this work? Expression must be pointed to complete object. Why does it not work? Okay, what if we try this? Float star p temp float ptr pointer is equal to vertices 44 cast as float star float pointer. Then we take this, plug it into here. There's going to be 6 of these. Really interested in why this does not want to work. Okay. Do we want to exit? No, let's just run it. So size is 24 because there's 4 floats in each vertex, because there's 6 vertexes. There's X, Y, Z, and W, which are the texture coordinates for the font, for example, in this case scenario. What happened? Did we break somewhere? Why did it just stop? That's weird. Oh, it did that. Okay, whoops. So it seems to allocate right. Okay, so we got to this. Okay, Y is 3 and 4 is 0, and then these are not. Oh, because that's the position. Okay, so that makes sense. It's not drawing anything though. that doesn't make sense. So really we would have to printf all of them. So let's just, I don't know how I'm going to recycle this, but for int I is equal to 0, I is less than I size I plus plus, and just loop through this so I don't have to keep writing crazy, stupid, repetitive code. And let's see if that buffer overflows. It might. It's like loading or something? What's wrong here? It does that malloc. What is issue? Why does it need a tissue? Okay. It's stuck? What's wrong here? Where is it even at? Interesting. Let's look at the memory size. Yeah, so it had a little hill. Went to 55. Something else. Oops, it was the same thing again. Okay. Alex. Some random place in memory. It was good. I don't know why that doesn't return 0. That might be an issue. Let's go fix that real quick. I'm not going to fix it later. I know how I work. I just, oh, whatever. It worked, so who cares? Okay, that is to be like that. Might be not an important thing, but yeah. Could have sworn I saw that shader. Oh, wait, whatever. I think it created it right. It shows the right stuff. It's reading from the same address location as vertices 44 and showing the right data if I loop through it. And blah, nothing. Why? It's not that much coordination different than the other one. Unless I put the bound right here, which I already bound it. But I'll try to bound it again and see if that's the issue. Nope. The only other thing I could check is shader. Yeah, some bind buffer VBO. Part1 alloc graphics. Take this crap. Put it into here. Which I might just slap this in there. But what if I put this here? Right before that. Like it usually kind of is. Don't see the difference though. I'm just going to change this to dynamic soon, I think. Yeah, so that's one, that's one. That's some address, stuff in it. What if we put buffer data under the vertex declaration stuff? Attribute pointer thing. So I only think it has to be something simple. Okay. Put this back. Okay, so why not work? Let's go to our draw function. Try that. Might be some code somewhere else interfering with it. I don't know. I don't know what else it can be. Can I pull the data out? How do I pull data out of the GPU? I know I can do the get pixel thing. Might be better to Google this, but who cares? Code in C, get out VBO data from OpenGL 3. This is sort of an auxiliary function. We'll put it up here. And then before we go into while loop, 24. And we retrieve it. Set breakpoint here. VBO is our VBO. We didn't bind VAO. Does VAO get unbound? Yes, it does. Let's bind them before we do this. Try to do this properly. The fuck? I could have sworn I just did an allocation function. Oh. Put this down here. Whoops. What else did this say? Oh, free it. Whoops. That's so dumb. Okay. What does this say? Yeah, it's in there. Retrieved VBO data. No, wait. Why is it dividing by 4? Huh. And it only got 1. Oh, actually, it's 1, 2, 3, 4, 5, 6. At the wrong offsets. It's the right stuff. It's 24. It retrieved it wrong. Alright, let me rewrite this a little bit. Get rid of this. Put this here. Make this obvious. VBO $D, which will be the I index, colon F. Put the I right here. What did it say? Why do we have trash in there? So it only did the first 2 points right. Okay, that might be the problem. Because these triangle thingers will not work. Why do we have trash in there? So it assumes, it doesn't assume, it just doesn't copy it in. Why is it not copying my stupid stuff? My arrays. My beautiful creation, whatever. Okay. Crap, shit, damn it. Alright, so this is 24. Since there's 4, let's times this by I num at 3 boots. And that's the issue. Inum attributes will be the amount of stuff. So it's confusing because float is 4 bytes and the amount of attributes is 4. So that like always confuses me. Always. You have to do a lot of like bitmap. Not bitmap, bitmath. So let's see. We do bitmap, bitmath. Okay, what did it say? Oh yeah, it's displaying our thing. I could see it already. It said, why does it say the wrong shit again? The fuck? That's the wrong thing, but it's displaying our thing. I know why, because it only retrieved so much data. But it helped us figure out the problem by telling us the size differential. Okay, difference. Okay, so 24 times 4 is equal to 96. Okay. So if we treat this, just run it again. We need to free retrieve data. Let's free that. Oh crap, it went all the way over here. Let's go back to here. Make sure we don't have this memory leak. I know it's a small thing, but it's just like really good in case you're doing it more of this C style, managing your own memory all over the place. There's a very good thing about it, that's the performance side of things. There's the code stack, the stack. There's the code segment, data segment, and the stack segment. And that's the first thing you learn in assembly code. Versus compiler, where it's a little different. There's like more theory about compilers and more theory about actual programming. In actual programming, they teach you a lot of different approaches, I like to call them, in Java versus C++ versus assembly. In assembly, the approach is know how much code segment, stack segment. And there's also a thing that they start calling a heap, which is pushing and popping is what happens when you call a function. When you push out of a function, you pop back into it. All right, let's refactor this. We figured out what the problem was, and it's such a stupid little problem, and I didn't think it was. I was just trying to save way too many bits and bytes. I was being too greedy. That was the problem. I was being way too optimizationist, which is good, and it's very deadly because it can cause long strides of pain and suffering trying to just achieve something simple. But it's, what's it called? Very rewarding in the end. So kind of like those two always like to collide with each other. Oh, you want to do something rewarding? Pain and suffer. All right. Aside from the math lectures about how I should be putting into classes and actually doing math, instead of optimization masochism. It's like some people would say like OpenGL is old, we already know how to do it, but no, this like going back to the basics is always good. So you then go into something like Vulkan and really not have too many mistakes, and that's nice, I guess. Or DirectX or Metal. All right. Yeah, so I wanted to refactor. First thing I need to refactor is just some garbagey stuff. Then I want to add some stuff. And then later, yeah, it's like there's like 4 steps to take at least to just start getting the text back up on the screen. And then at like step 6, I can start ripping stuff out. It's going to look quite different than the original. Okay, where's our bind? All right, this is where it was. This stuff, let's try to make that not here. This we will truncate. This is left here for in case we do need to debug. This can now be transformed. It's like miniature amount of bytes here, optimization, but that's the point. Everything has to be perfectly aligned. Still in the storm of a pirate ship fighting, it would still all function fine and be optimized and have its agility. Alright, what we forgot is the thing that calls this needs to do that other thing. I really certainly need to getting rid of that crap. So before this calls this, or is it? Did I just erase it without uncommenting it? Yes, I did. That's okay though. Part 1 graphics, yeah. Okay. We left this one over so we can keep calling it. Could do. Can be different versions of this. Float, quad, X, float, quad, Y, float, quad, width, float, quad, height, you could also put in the texture coordinates. Oh no, I don't want to do that, but whatever. Just copy paste this real quick. And the problem is I didn't do the UVs right on this. Kind of screwed up, and I have all this garbage here. I don't know what half of this is. Guess we're gonna need this guy. We're gonna need some sort of variables, but not these. That'll be something like quad x minus quad width divided by 2. Box's start y will be y quad height divided by 2. Alright, so we got that part done. Oh yeah, we need end. Oops. End. And then we just copy paste what we kind of had here. I need 6 of these. We got to make a quad class or struct. Have to just like destroy this. I got to get the first quad right here. So boxes x is the start. No. Yeah, it's 1. That's the more negative. Oh, okay, so this I forgot to do. So just be a plus of what the boxes end x equals quad x plus quad width divided by 2. The division should go in first, order of operations, but we're going to put parentheses around this just to be like direct about it. Who knows? Okay. So these are both starts. To replace this box x start. We will destroy this. UVX, box UVX, box UVY. I guess this will be X naught. And Y naught. The texture coordinates I might mess up on. Who knows? But we will follow, like, if X is great, then it's 1. Certain things may have different texture coordinates, but that's why they're parameters. To get past it. Alright, so we got that. So we got X is greater, so it's X end. We'll try to bypass this and kind of comment it out. And once we're done, we just erase it. Boxes is still the same. Oh wait, we forgot to do this one. Start boxes Y. Boxes start Y. This is boxes end X and boxes start Y. UV coordinates will be different for this. The Y will be same, X will change. X will be 1. Okay, so vertex 2 is done. Let's copy paste our little diagram. Oh, it's already copy pasted here. Good. And the YouTube videos on how to do all this. Okay. So now X and Y gets switched out. Oh, it doesn't. Yeah, it does. No, it doesn't. Yeah, it does. Okay. X is a start. So let's get switched out. That's confusing. Okay, start. Y start. No, it's Y end. Okay, we're done with this. Okay, UV coordinates. So they should be opposite. So it's X UV X0 and UV Y1. I don't want to scroll all the way up to do that. It's just like a waste to scroll. Carpal tunnel problems. I had really good scrolling mouses. Then I figured out what gave me like something like carpal tunnel. There's like another one. It's called something else, but it's like right on the same part of the nerve. It is good to go relax and do push-ups with this because really get crazy at coding. Okay, enough health lectures. Okay, this, they're both end. You can borrow and end. Oh. How come these are both start? They're not supposed to be. Okay, this is vertex 3. It's start and Y is end. Oh, I messed up on number 3. For whatever reason. Okay, that looks right. Okay. Now, numero cuatro is both end. So we know we have end and buffer and X. So we got done that. So this will be both UV, X, and Y1. Get rid of this. Slowly building up to it. Okay, we're on vertex 5. 2 more vertices to go. How exciting. Okay. Boxes start X. This is just quads, but we are building support here for triangles. Because triangle is your best sprite type, since it's the most efficient. You can make very efficient game with this. Okay, and boxes and Y. I love boxes. Okay, and comment this. The UVX will be 0. UVY will be 1. Erase this. Okay, vertex 6. Boxes will be end. Boxes start X will be end. And boxes start Y will be start. And UVX will be 1. And UVY will be 0. Right? Yeah. Correct. Okay. Affirmative. All right. And we returned 6 of how much we allocated. So now we have our little alloc to CPU GPU block. This is a quad. Now let's try to for loop through this. Let's try to add it here toward the end. Oh, I'm confused. Why am I in weird land? Oh, it's just like playing tricks on my eyes. Looking at this like over and over again. Okay, that's okay. So num vertices is equal to 6 times that. So we know we put in 6 here. So it'll be plus, that's a new variable, I num allocated is equal to 0. Make sure I didn't then for loop through this like 10. And I equals 0, I is less than 10, X sign thing, plus, and X that's been rotated by 45 degrees. Okay, and num allocated will be plus equal to whatever inum alloc GPU block. The quad X, change this to 1. So let's go like this, redo. Okay, that's good. And then we will make this into, since that spans to 60, set this to 55. We'll make the width and the height. Let's copy paste this. We want to change the variable lines. Even though it's it's gooder to change them. Put like the letter L, which stands for local. Let's put local in front of all these. Let's take this, copy paste. Oh wait, let's put L in front of them first, then copy paste them. Oh, whichever way is more optimized, doesn't matter. Okay. Just kind of arrange this like this. Just get rid of the float in the function. That way I kind of was able to do a little bit less work by doing it this way. By just like copy pasting out of the function. Alright, so our width will be, we want this to fit, we need 10 of these to fit. So I need it to be like 0.005 f across like the x horizon. And we need to make x position equal to, we could use the modulus in order to like keep going on the same thinger, on the same row, or like increment rows. We'll just go is equal to I times cast float. You don't really have to, but it's better to. It's times, I hit insert key. I need to get better keyboarding position. And notice that I keep screwing my code up because I can't code super fast like I used to. The better keyboarding position. 0.05 f. We want the width to be smaller than that, so 0.4. Same thing for height. UV10 is equal to 0, because UVs run from 0 to 1.0, while the screen runs from -1 to 1 in both x and y. So we set that up. It's our allocation quad. Why is this not happy? Okay, we just need to erase this. Okay, allocated another quad. What we need to do is add to the 6, this allocation num variable. That way it, oh crap, like how does printf did it do that? Okay, let's just run this thing. Don't even bother. Nope. They should have been like down here. No, where should have they been? They start out at 55. Huh? Okay. I'm very unhappy. I am unhappy with Okay, let's make 10 of these. Oh, they just put a breakpoint in here. Oh, did I? Maybe I missed that. We'll put breakpoint here, I guess. All we need to really check is X. Alright, we gotta go check this out. See if our calculations are... Oh, we have minus sign here? Oh no, I missed that. What would that do? I think it makes a flat triangle. Whoops. Stop that. Pardon my mistake. I should have hit Control F5. It's faster. Check. The other thing I should be checking, num alloct. Alright, that's good. Huh. Let's escape real quick. Let's go check our log. What the WT? Okay, so we have a lot of garbage now. After 24, why is it all trash? Yeah, after 23, 24 is like trash, trash, trash. For some reason, 26 and 27 and 62 and 63, I guess they got just initialized to 0 to whatever memory they were. And these are like -1. That's a pretty nice value right there. I wonder how much that is. -1,000. Alright, so we got this. Now we need to just figure out why the function isn't throwing our data in there correctly. Almost the same problem we just had. Yeah, vertices dynamic. It's the same thing we were using over there. It's a static global variable. I don't know. Alright, so it does print us the address being incremented out of the box. Can we just go check that? Yeah. Yeah, so it's putting these values in here. This looks valid. This looks okay. That's the first one. Okay. This is the hex offset, or it's actually in decimal, but we can see it better in decimal being incremented by, I want to say 4. Yeah, it is 4. No, it's like 12 right here. It's usually 4, but sometimes it's 12. Whatever. Okay, so these are right. But why is it 12? Sometimes. It's not linear. Do we have to mem copy it or something again? Well, it's between the 1 and the 2, so that seems like 36. Something's wrong with it. Oh, 1, 2, 1, 2. It's always 1, 2, 1, 2. Still though, why is that 12? think it's the amount it's sending again. Num allocated. Oh. I don't think this really matters, but I think we need to add, because order of operations will times this by this first. So we need to add first. So that's a really important. And that's the problem when you have these like just wobblers. I call them wobblers because they're always around with testing. You never want them. You want everything to be dynamically allocated. And wobblers create the most sort of difficult problems because, like, what is this 6? And what this 6 is this first test block. But we need the test block because we're testing. Very interesting problems. Okay, let's see if that helped. It should have. Okay, by now, okay, number of vertices 1,500. Okay. Make sure we don't hit our limit here. Uh-oh, we're still bad. Can't believe that that didn't work. That should have been the problem solver right there. Why though? Alright, so we have the first 24 are okay. And we start getting trash. It only goes up to 95. Or 96, sorry. Should be divided by 4. What if we're sending in too much? Oops, okay. We have to reincarnate this thing before we send to GL buffer. And what did it print? It printed that we're bad. OpenGL memory allocating people. Okay, so this was good. This was bad though. So it only goes up to, let's do the math, 264. So 264 divide by 4, divide by 6. Yeah, there's 11 elements. That's how the math works. We have to go check our calculation here. So the memory, it read right. So every time that's 6, right? Num attributes. So is this num attributes extra? Like, I don't get it. It's being stupid. So we have 164 divided by 4 is equal to 66, right? That was the first thing we did on the calculator? Yeah. No, 264, sorry. Which is the float. Then we have divide by 6. And num attributes is 6. So we need to, I think, get rid of num attributes. Right? Because there's 6 per thing. We're already taking it into account right here. 6 plus, and this will be 10. Oh, that's wrong. 6 is 1. 10. No, num allocated is going to be 6 every time. So that's going to be 60 plus this will be 66 times 4. Just note it right here. Right? Okay. Okay, I could multiply and stuff. But I still don't see how that would cause us a problem. It might cause a problem here though. Because it might not be enough right here. I think we need to do the math again right here and times this again by 4 or 6. But we already times by float. But we have 4 attributes. So I guess that's not a times by float, it's a times by attributes. Let's go look at that again. This is the fun part, figuring this out. This is 4, but there's 4 attributes. So there's 6 of these. Alright, so let's bring back, instead of that, I think it should be like that. I think. I don't know. We'll find out. What we need to do is just pull out what's in the buffer and just see what's there. Just increase that buffer size thinger. Okay, what did it print? Still didn't work. Something's still wrong. Okay, 95, 96, after 23, we got trash. Okay, that printed till the end, right? Retrieve VBO. Okay, we didn't retrieve the VBO right. put 264. This is where the first quad ends. And how come it doesn't put more stuff into here? Like this, some of this stuff is valid. All the way up to like right here, 65. Man. Okay. There is another thing though. I forgot. I forgot to like draw more. There's 66 of these. It went from 24 to 66. Doesn't make any sense because we made 10 of them. So it actually should go all the way to here. Let's times that size by the float when we pull it out. Actually, it's 66, right? 66, it would still be the same number I just put. Huh. But we have to malloc this. No, it malloced that. Like, it was that already. Maybe make it this? I don't know. It's being weird. Okay. Just increase the size of pulling out stuff. So you hope you pull out good stuff. Then when we loop through it, though, I think it has to be a smaller value. Or something. Yeah, because it's going to be too much. Right there. Or something. Nope. Why? Why? Alright, that looks good, that looks good, that looks good, that looks good. It looks good all the way. We just pulled out too much crap. I think it was dividing by 4 in that other for loop. And that was the reason it was doing it. That's so confusing though. Whenever you do that, you have to like divide by 4 whenever you're dealing with these two functions, GL buffer data and for looping through the shit. It's a different offset thing here. One is in bytes and one is in floats. It's a different offset count, basically. I'm so confused, I'm never going to figure this out. but maybe someone else watching this can. Okay. Let's go back to main. What was the thing we modified? I'm just going to hit Control Z. Go back to this. Inside of for loop, do temporary repair by dividing by size of float. It should actually cast it to a constant predefined. Alright, so that should be good. Now we need to go into a draw function. Before we do, let's create our main structure here. It'd be nice to make an engine structure. And just like make it. Let's maybe try to make it. Our structure will be, I think some people do type def struct or something, right? Put the name here. Some people call it state engine. State engine, I don't know, render. I actually don't want to name it too crazy. Okay, first thing is going to be float star, vertices dynamic. Next thing will be int I num draw int I start draw? No. I num draw, no. It'll be I num vertex is, so you could like pass stuff in there but not draw all of them later. So you would also need a start quads or render triangles, sorry. Lines and points. You could re-replicate the data or recycle it. I start and I end. And there may need to be a vector of these. We'll find that out later. We just need to create like a quad class. Somehow integrate some of this into it. Okay. We'll call this global. Let's go state render engine. This global variable. Now we need to put stuff into it. Okay, so whenever this gets allocated, we also need to throw it in here, which makes it look kind of ugly, but it's kind of worth it. So state global dynamic. After we're done with our create all the quads function, did we draw all the quads yet? Like, what happened with that? Oh no, we can't, because the function is not ready. I have to make a global variable for the amount of quads we have, because later that moves up, it upgrades us faster. Yeah, I should just do it by hand, but all right, kind of hacky upgrade. It's really, this function never pops up here. Okay, for some reason the capitalized stuff is before. Capital letters do go before lowercase. No, in ASCII, which one goes first? So if this was instead of 6, 264, would this work? Or would it be a lesser value? Alright, so we got our little thing. It looks like a Half-Life 2 stamina bar. Cool. So what will really go in here? Okay. We need to start deprecating some of this. But we need the text to work before we deprecate it. Because this is the cache quad code for now. And then we have to make a new project and start adding GLTF into it and changing the shader. Like, we have to work on adding a few more attributes to the shader. It would be nice to also like start working on the renderer, but that's like too much. First, it needs to have a default modeling text. I would like to have triangles and points and lines too. But like, I think in the Vulkan and maybe even in the metal pipelines, because metal literally means something like Vulkan. It's like bare metal. The metal compresses, and I don't know if they have the standard pipelines for dots and lines, but we can make that too, I think, at some point. It could be done like all at once, but you still have to subdivide it in terms of logic, I guess. Okay, so we have to go back into our little make all these quads stuff function. Just get everything up and running. It's our first quad. Okay, and this, once we sent this to GPU, we want to do it here or over there? This is the real question. I kind of want to do it in this function, but I don't want to put more clutter in here. This is more the cluttery function. Okay, inum vertices is going to be equal to inum vertices. We're going to need to make sure, double check, and then we take this and put it into the render function. That way, like, when we just start adding more quads, just tell it, oh, okay, just draw a ton of quads everywhere. The thing it doesn't have is, like, color, but we could add that. That's the thing, you want this simplistic thing to work first. Why? Because all the issues with the memory, there's always going to be this issue where something is not aligned right. It's like first you get it aligned once, and then you're still going to keep realigning it. Okay, now we need to go back to render function. So each, like a little iteration of engine upgrade causes a lot of things to change. It seems like it would be like 2 changes here and there, but it's not the case. Because the code needs to like be updated and deprecated and mutated. So 18, this is the wrong function, isn't it? This is the right function. Okay, we want it like that. It would be nice to also change the 0 to start off somewhere. There's no time in here, so we can kind of like play a little game. I hope it knows what I mean. Oh, it seems to know. Ooh, I could have just copy-pasted this code. Okay, so actually he made a really interesting code here. T equals plus max vertices, vertex count, line strip. Oh, so there's GL line and then there's line strip also in the default pipeline. It's not what I wanted it to do. I hate how it does this. It loves doing this now. Like, what is it doing? I think it's a mutex error, my keyboard. I don't think it's Visual Studio that does that. I'm not sure. I gotta figure that out. I want it to be time-based, but what if it's just this? How would that look like? Huh? What did it do? Looks like that got attached to that. Huh? Oh, I see what the error is. Start triangle is never 0. So you can't see it. I think it's doing it way too fast for my eyes to see. That's the problem. Huh. Doesn't seem to be any changes. I wonder why. It has to increment it by some very small amount. Or something. What if, like, start triangle is like, I don't know, 24. There's no increment.
I'm gonna go for a little break. The next part is kind of exciting. It's making me very hungry or something. Okay, so what would happen if we did this? Just temporarily fix their parts of our shader. I know that this will mess it up completely. Let's see what would happen if we have texture. Yeah, it's not always good to have texture, but sometimes it is. Text color times sampled. It's like multiplying vector 4s or something. So it's not because the texture is not applied or not compiled. Let's look at that again. Texture coordinates of red. It's only getting the red color of the texture of these coordinates. Oh, it's setting the color to that's weird. Texture coordinates should be getting passed in. Okay. Let's look at our other render functions. Use shader program. Bind texture, texture ID. It'd be nice to like load in the texture, merge it with the it would be hard to merge it with the model texture and the text texture and a custom other texture for UI. Wouldn't it? But it's possible to have it all one sampler. That's like the hardest part. The hardest part. Set active texture 0. Need to do is probably do it here. It's going to be a little hack, but whatever. I don't know why I picked 36, whatever. I don't know if I need to call set active texture. should have some valid UV coordinates, or do we? Let's go look at the UV coordinates for a second. It should be like 10, 11, 10. I could have messed it up though, but I shouldn't have messed it up on the big one. That looks invalid. Oh no, those are addresses, sorry. That looks valid. Huh. Why though is it so screwed up? I haven't seen this GL active texture thing. Okay. Will this do anything? No. Let's see here. One little thing. Let me try. Just I forget. Is the texture sample or vec4? I guess we'll find out. That's their like default texture cube shader right there. Color equals texture. Oh, it's the wrong code. Wait, it's the right code. Never mind. Texture sampler equals text. Text coordinates. Okay. In, out. Okay, that's right. Okay, they're red. Yeah, it did get textured. It's like trash from the font stuff. It's all the fonts like inside one. This is the wrong texture coordinates. So it's red. One other way to kind of tell. It's just texture the big one real fast. Do like negative, 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 negative. So if the first one is top, do 1, 1. This one is 0.5. This fast. This one is 0.5. These are both 0.5. So it'll actually just texture the color. Because you could have a color map. So you don't have to do less if statements. Like you could save doing shader instructions by instancing it by the coordinates of the UVs. But I've also stuck types into UVs and other stuff. So let's start to get some more stuff like this, but still have to organize it. I've got one UV wrong. I got the others ones right. Okay, the one I got wrong was from triangle 1, in the bottom corner. bottom corner. It's 1. I didn't get one wrong. Yeah, I did. I just thought I did. Okay. Yeah, there we go. Something's still really wrong though. It's not textured right. It looks really cool though. It created like new characters out of that. You could like take a screenshot of the screen and take this. Alright, but I should figure out why that's wrong though. Okay, this is the top. Oh, I see why it's wrong. I think that's why, because whenever it's bigger, which is negative bigger, damn it. The next thing we want to do is like start rotating these two, not just the text. Is that right? Why is it upside down? Is it all upside down? Yeah, it's all upside down, so that's right. Because the other ones are like boxes. Okay, good. So we know that works. Oh wow, this is getting cluttery. Yeah, really we'll need to start to move this out into a bunch of files. Get a camera going. 2D camera. I forget what the 2D camera's for. Maybe the UI. You can have the UI camera. There's some other stuff. Ah, damn it. I forgot what the 2D camera was kind of for. I guess we can keep the double sample point. The problem with this is the text color has constant 1.0. That's causing it nothing to be transparent, which is annoying. But since it's like sampled, it's a vec 4. So you have to times it by a vec 4. You can't make it a vec 3. And this is using the alpha color. Yeah. And that's really annoying. I mean, this. How would you fix that? Go back to what it was. So the text color, one way is to get rid of text color. What if you just have a plain quad? Then you set its UVs to be something within that's textured that has an alpha value or has partial alpha value. I'll just change its type.